Hey guys, how are you? This is Mr. Chavla, and in this video I'm continuing the part 1 key for June 2017 Algebra 2 Common Core exam. I did number 1 through 9 in the previous video, and I'm gonna try to get through number 10 through 18. I might end up doing a little more or less. And again, this is Mr. Chavla or Mr. C. I'm gonna try to get through 10 through 18. I might end up doing more or less depending on how long it takes, but let's get started. Number 10, and again I did 1 through 9 in the previous video. So number 10, we got right here, a game spinner is divided into 6 equal-sized regions, as shown in the diagram below. So they numbered each of the regions 1 through 6. For miles to win, the spinner's got to land on a 6. So I'm just going to write here, he wants to land on 6 to win. So after spinning 10 times and losing all 10 times, Miles complained that the spinner is unfair. So he spun the spinner 10 times, 10 spins, no wins, meaning he never landed on 6. He complained that it's unfair. What that means is that the spinner is somehow rigged. Like, if you spin it, there's a higher chance on landing on one number compared to the other. And he's thinking that there's less chance of landing on 6 than landing on some other number. And that's why he lost all 10 times. And so spinning 10 times and he didn't even get 1 6, so he's thinking it's unfair. So at home, his dad ran 100 simulations of spinning the spinner 10 times. All that means that one simulation run means that's 10 spins on the spinner, right? 2 simulation runs is another 10 spins, and we're recording the results each time to see how often do you land on 6. So maybe in one set of 10 spins you got you landed on 6 one time. Maybe on another set of 10 spins you got no 6s, right? And on another set you got maybe all 6s, who knows, right? But that's what he did, and he assumed that the probability of winning each spin, which is again landing on 6, is equal to 1/6. That makes sense because there are 6 equal-sized regions, right? So landing on any number should have a probability of 1/6. So this is assuming that it's that the spinner is fair, right? That means that there's equal chance of landing on any of the numbers. So the probability of winning is 1/6. The probability of losing will be 5/6 because the probability of landing on any other number besides the 6, there are 5 other places it could land on, right? So the output of the simulation is shown in the diagram below. So make sure, guys, you understand what the simulation means. The each little dot represents 10 spins. So that means that in this, I'll highlight right here. In these ones, any one of these dots represents 10 spins, in which 40% of the spins landed on 6. When spinning 10 times, you got 4 6s, in other words, right? So out of 10 spins, sometimes we got 40% 6s, and sometimes we got 30, 20, 10, because remember it's 10%, right? So this would mean you got 4 landed on 6 4 times. It never happened more than that, which makes sense. It looks weird having 2 numbers here. Land on 6 4 out of 10 spins, right? And that happened about 10 times. Remember, each dot represents 10 spins. So 4 out of 10 spins were landing on 6, and that happened 10 times. Now at the lower end, this is what happened to Miles, is these are the times when none of the 10 spins landed on 6, because it says proportion of 6s, right? And each dot represents 10 spins, so each one is separate. So if we see, remember he said it's 100 simulations, so there are 100 of these dots. 20%, 20 out of 100 simulations got 0. I'm going to minimize me now. This is 20 out of 100, which is 20%. Of the simulations had no wins, right? Or never landing on 6. That's not unusual, because remember he's saying that he's using a fair spinner. So landing on 0, I'm sorry, not landing on 0, failing to land on 6 in 10 spins is not unusual when spinning a fair spinner. That could happen. It doesn't happen all the time because in the other about 80% you get at least 1 6, right? But 20% is not unusual. Unusual is usually like less than 5%, right? But about almost a quarter of the time, you could expect that, okay, if I land on 6, just because, I mean, if I spin 10 times and just because I didn't land on 6 at all, doesn't necessarily mean the spinner is unfair because when I spin, even if it's a fair spinner, there's like a 20% chance of not landing on 6, which is not unusual. Okay, if it was less than 5% of the time, then I wouldn't expect that to happen and I would suspect the spinner is unfair. So let's read the choices now. Which explanation is appropriate for Miles and his dad to make? Anything that's, so choice 1 is saying the spinner is likely unfair. No, no, no. We know it's probably fair, all right? Um, because he failed to land on 6 20% of the time. The next one is also saying the spinner was likely unfair. Nope. The spinner was likely not unfair. Now you have my attention since the number 6 failed to occur about 20% of the simulations. Exactly, 20% had no wins, so it's not unusual in a fair spin when spinning a fair spinner. All right? And I'm not even going to bother looking at choice 4. All right, answer is choice 3. You need to know about your sample proportions and understand how to read these simulation diagrams. Okay? Um, they didn't mention anything about a normal distribution. Then we could have used the mean and standard deviation, but we won't even worry about that right now, okay? So that was number 10. It took up the whole page. Let's go to number 11 now. Which binomial is a factor of x to the fourth minus 4x squared minus 4x plus 8? We could use our calculator and just see which one. Factor means that when I divide, I get a remainder of 0. Or basically, if I look at choice 1, for example, if x minus 2 equals 0, then x equals 2. Substituting, if x minus 2 is one of the factors, substituting x equals 2 into the polynomial should give me 0. If x plus 2 equals 0, and x plus 2 is a factor, substituting x equals negative 2 into the polynomial should give me 0. So I'm going to just call this polynomial f of x, right? So if f of 2 is 0, then x minus 2 is a factor. So I'm going to just use the calculator very quickly. We could do it by hand. Yeah, I had the answer key there because I wanted to make sure I didn't make any mistakes. All right, so I was double checking. Okay, so what I'm going to do is I'm going to make a table of values. So I don't need this. We could have also used the graph, but that's one of the ways to do it. And we could do it by hand. We don't need this, but let's just say f of x equals x to the fourth minus 4x squared minus 4x plus 8. And let's get a table. So we have x and f of x, right? And if x minus 2 is a factor, then 2 should give me 0, which it did. When x is 2, I got 0. So since f of 2 equals 0, then x minus 2 is a factor. And we already got the answer. That's the remainder when I divide by x minus 2 will be 0. If I look at negative 2 now, I get a remainder of 16. So x plus 2 is not a factor. All right. If I look at 4, I get 184. So x minus 4 is not a factor. And for negative 4, I get 216. So x plus 4 is not a factor, right? It's choice 1. And I could show you guys by hand as well by substituting x equals 2 into the polynomial. And here's what it would look like. So all we're going to do is choice 1. The value I get is the same as the remainder if I was to divide by that binomial. So for choice 1, x minus 2 equals 0, x equals 2. And I'm saying that f of x is equal to this polynomial, the whole thing, right? Then f of 2 is equal to 2 to the fourth minus 4 times 2 squared minus 4 times 2 plus 8. 2 to the fourth is 16. 2 squared is 4, and 4 times 4 is also 16. 4 times 2 is 8, 8 plus 8, and then this is plus 8. So 16 minus 16 is 0. We get 0 minus 8 plus 8, which becomes negative 8 plus 8, which is just 0. So the remainder when I divide by x minus 2 is 0. The remainder when I divide f of x, this polynomial, by x minus 2 is 0. Therefore, x minus 2 is a factor of f of x. All right? Let me say that again. The remainder when I divide f of x, polynomial, by x minus 2 is 0. Therefore, x minus 2 is a factor of this polynomial. Okay? And we know that simply because f of 2 equals 0. Therefore, x minus 2 is a factor of f of x. Okay? We're going to move on to number 12 now. Given that sine squared theta plus cosine squared theta equals 1 and sine theta is equal to negative square root of 2 over 5, what is a possible value of cosine theta? So all I'm going to do is I'm going to substitute in the equation sine squared theta means I'm squaring this plus cosine squared theta equals 1. Now, if I square a square root, I could put this in the calculator, but when I square a square root, it just cancels and it becomes positive. And 5 squared is 25. Now 1 is the same as 25 over 25. So if I subtract 2 over 25 on both sides, and I could use the calculator, but it's not necessary, I get cosine squared theta is equal to 25 over 25 minus 2 over 25 is 23 over 25. Now since all of these are positive, I'm just going to take the positive square root on both sides. I could put plus minus, but since they didn't give negative numbers as an option, it's 5 plus positive, 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 positive. Cosine theta, when I'm taking the square root of a fraction on top, square root of 23 doesn't simplify, but the square root of 25 is 5. So square root of 23 over 5. The square root of 23, and then that radical expression is divided by 5. And that's choice 2. Square root of 23, and then divide that square root of 23 by 5. Divide that square root of 23 by 5. And our answer is choice 2. All right, moving right along to number 13. A student studying public policy created a model for the population of Detroit, where the population decreased by 25% over a decade, which is 10 years. He used the model P equals 714 times 0.75 to the D. So guys, if it decreased 25%, that means 100 minus 25, 75% is left. That's why it's multiplying by 0.75 in a decade. And it started at 714, where P is the population in thousands. So that means the initial population is 714,000 people. D decades after 2010. Another student, so this was one student, now another student, Suzanne, wants to use a model that would predict the population after Y years. What model could Susan use? So here's what we're going to have. We know that P, and I'll use function notation, of D is equal to 714 times 0.75 to the D, right? What I want is, a decade is 10 years, right? What power would I need to raise this in order to make it so it's in terms of the yearly decay factor, right? If I want it for 1 year, I divide by 10. 1/10 of a decade is a year. That makes sense because 10 years is a decade. So since I want to scale down, I'm going to raise to the 1/10 power to find out what I multiply by in a year. So for a year, right, I'm going to multiply 0.75 to the 1/10 each year. Because 10 of these, if I raise this to the 10th power, that's how it becomes 0.75 again, because yearly decay factor right here, if raised to the 10 power in 10 years, would give me 0.75 again. That's how I multiply by 0.75 in a decade. So I'm trying to get the eraser tool here. So basically, I just want this. And now I want to find out what 0.75 to the 1/10 is, and that's all I need to do. And I'll use this one. So 0.75 to the 1/10 is about 0.97164, which makes sense because the population isn't going to decay as much in a year as it does in a decade. 0.97164 something, which is about 0.9716. So the population after y years can be given by this, right? Because if I raise this to the 10th power in a decade, it'll give me about 0.75 if I raise 0.9716 to the 10th. Okay? So answer is choice 3. It's just knowing how to manipulate exponential functions for different time periods. All right? Now we're going to move on to number 14. The probability that Gary and Jane have a child with blue eyes is 0.25. I'll write that right here. So blue eyes, the probability of blue eyes is equal to 0.25 or 1/4. All right, you don't have to put the 0 there, it's messing things up. And the probability, I need to put the charger in soon, so and the probability that they have a child with blonde hair is 0.5 or 1/2. I was going to use B, but then they're both B, blue and blonde. Blonde hair is 0.5, which is 50% or 1/2. The probability that they have a child with both blue eyes and blonde hair is 0.125. And blonde hair, I believe that's 1/8, and I'll confirm in the calculator. So let's find out what that is as a decimal. 0.125 as a fraction is 1/8. So that is correct. So let me put the charger in so that the computer doesn't die on me here. Alright guys, I'm back and computer's charging. So the probability that the child will have both blue eyes and blonde hair is 0.125, which is 1/8. Now you didn't have to convert them into fractions, but I felt like it would be easier to work with if we did. Alright? So given this information, the events blue eyes and blonde hair are, so guys, if they can't be both 1 and 2, right? Dependent and independent. So here's how it goes. If they were mutually exclusive, they cannot happen at the same time. That's option 3. Mutually exclusive means they exclude each other. They do not happen at the same time. I realized I spelled it wrong. That would mean that the probability of, I'm just going to write blue eyes and blonde hair. This is just the symbol for and. Okay, I'll write it in case you're not familiar with it. The probability would have to be 0. They can't occur at the same time. That's not the case because that probability is actually equal to 0.125. So option 3 is out, which means we eliminate choice 3 and 4 since anything that contains option 3 is incorrect because it's saying given these information, the events are what? So it's not choice 3 or 4 because option 3 is no good. And it can't be both 1 and 2, so it has to be one or the other, right? So two events are independent if the probability, so if A and B are independent, the probability of A and B is equal to the probability of A times the probability of B if they're independent, right? If they're not, if this is not equal, then the events are dependent, okay? So let's just find out. So the probability of blue times the probability of blonde, and now it'll be easier to do using fraction. Is it equal to the probability of blue and blonde? And they're not, the product isn't always the same. So I'll do it in fraction form. If you want to use your calculator and put it as a decimal, that's fine too, but you'll see it's easier to do it as a fraction now. Blue has a probability of 1/4. Blonde has a probability of 1/2. And we want to know if the probability of both is 1/8. If I multiply the numerators, I get 1, and multiplying the denominators, I get 8. 1/8 is equal to 1/8. So therefore, the two are independent. All right. If they were not equal, it would have been dependent. So option 2 is true. So 2 only. So that means it's choice 2 for 2 only. All right. And choice 1 clearly is false because you can't have independent and dependent at the same time. All right. Moving along to number 15. And this is just about knowing about the probability of events and independence. You might want to look up something called the product test for independence. That's what we use. Number 15, based on climate data that have been collected in Bar Harbor, Maine, the average monthly temperature in degrees Fahrenheit can be modeled by the equation B of x is equal to this whole thing. It's a sine graph. And B is for Bar Harbor, and B of x gives us the average monthly temperature. The same governmental agency collected average monthly temperature data for Phoenix, Arizona, and found that the temperatures could be modeled by the equation P of x is equal to this whole sine function. Which statement cannot be concluded based on the average monthly temperature models X months after starting data collection? So let's take a look at the choices. So one is saying the average monthly temperature variation. The variation, guys, is how much the temperature goes up and down. That's given by the amplitude, which is the absolute value of whatever's in front of the sine value, right? So they're saying which one cannot be concluded, and I'll just highlight this here in yellow as well. Don't worry about the colors. They're saying which one cannot be concluded. They're saying the temperature variation, which is given by the A value, how much the temperature goes up and down. For B, the temperature variation, which is your amplitude, which is the absolute value of A. Our A value is the leading coefficient, 23.914. Since it's already positive, the amplitude is 23.914. But for A of x, it's only equal to, I'm sorry, P of x, that's ugly P, P of x for Phoenix, and B of x for Bar Harbor. The amplitude is 20.238, right? And they're saying the average monthly temperature is more in Bar Harbor, which is the 23.914, is greater than in Phoenix, which is 20.238. That's true. They want the one that's what cannot be concluded, right? So since that's true, we're going to eliminate that choice, all right? So they want to say which one's not true. The next one, the midline. The midline is just the final number you're adding outside the parentheses. So you take amplitude times sine of whatever's in the parentheses plus the midline. That's your average. Well, I don't want to use the word average because the whole function is an average this time, but they're saying the midline, average monthly temperature for Bar Harbor, is lower than the one for Phoenix. So this is our C value. So for Bar Harbor, it's 55.300, and they're saying it's lower than the one for Phoenix, which is 86.729. That's also true. The midline average temperature for Bar Harbor is lower than the one for Phoenix. That's true, and they want to know which one cannot be concluded. Now let's look at the next two. I'm going to erase this for now, okay? The maximum average monthly temperature for Bar Harbor is 79 degrees Fahrenheit to the nearest degree. So to get the maximum temperature, I mean, one of the things you could do is graphic, but that could be a lot of work. What you do is you add when you have a function of the form y equals a times sine bx, and don't worry about the addition and subtraction in parentheses, plus c. The absolute value of a is your amplitude. To get the maximum, you take the c value, the midline, and add the absolute value of a, the amplitude. To get the minimum, you take the midline c and subtract the amplitude. So choice 3 is asking about the maximum average monthly temperature for Bar Harbor. So for Bar Harbor, it'll be C plus A is 55.300, which is just 55.3, plus 23.914, because the absolute value of that is just 23.914. So let's find out what that is. 55.3 plus, I already forgot what the number was, 23.914. It's 79.214 degrees, and I'm going to make sure I use the right, yes, and that's rounds to 79 degrees, because it said the maximum is 79 degrees to the nearest degree, and it is. And remember they said which one cannot be concluded? So this rounds to 79, so to the nearest degree, It is 79 degrees Fahrenheit, and by elimination, we have choice 4. Okay? Um, and I like to write the choice number here too. But let's just make sure choice 4 cannot be concluded. The minimum average monthly temperature for Phoenix, so that, remember it's the midline, that's 86.729, minus the amplitude, which is the absolute value of 20.238, which is just 20.238. They're saying the minimum is 20 degrees Fahrenheit to the nearest degree. We already know if I do 86 minus 20, uh, it's gonna be, it's not gonna go down to 20. To get 20, I'd have to subtract somewhere between 66 and 67, I think, right? I'd have to subtract 66 minus 0.729, so clearly that's not gonna work. But let's just confirm, even though we really don't need to. 86.729 minus 20.238. It's 66.5-ish, so 86.729 minus 20.238 is, so 86.729 minus 20.238 is 66.491, not 20, nowhere near 20. All right, so the answer is choice 4 as to what cannot be concluded. As long as you know your sine and cosine graphs and how to find the minimum, maximum, midline, that the variation is given by the amplitude, you'll be good, all right? So number 16. Okay, I would have pulled myself up, my face, but I need space to write, so I'm not going to pull myself up right now. Or I could pull myself up, maybe. Let's see if I can do this. I might be able to fit after all. Okay, so here I am. Now, number 16. Which expressions are equivalent to 1 divided by the 6th root of x? So let's just take each of these expressions and see if they could be rewritten like that. So I'm going to look at option 1 first. All right, and I'll hang out over here. So option 1, we have x, the 6th root of x, which is the same as x to the 1/6 over the 3rd root of x, which is the same as x to the 1/3. Now, if you remember, when I'm dividing two exponential expressions with the same base, I subtract the exponents. So this is the same as x to the 1/6 minus 1/3. Now, I could use the calculator to find out what that is, or I could make the denominators the same. I'm going to just say 1/6 minus 1/3 here, just so that we could have it here, right? And I'll convert to a fraction. It's negative 1/6. So this becomes x to the negative 1/6. Because remember, when I divide exponential expressions with the same base, x, in this case, I subtract the exponents. X to the negative 1/6 is the same as 1 over x to the positive 1/6, right? And all I'm doing is I'm looking at option 1 right now. X to the 1 over x to an exponent is the same as, x to the 1/6, so the 1 stays the same, is the same as the 6th root of x. So the 1 on top stays the same in the numerator, and then the denominator raised to the x to the 1/6 power is the same as taking the 6th root of x. So they're saying which ones are equivalent to 1 divided by the 6th root of x. Here's 1 divided by the 6th root of x. This also became 1 divided by the 6th root of x. So option 1 is without a doubt true. It is definitely equivalent to that, right? So 1 is true. Anything that doesn't have 1, I could eliminate. So choice 3 doesn't have 1 as an option, so I'm going to take it out. Now if we look, guys, when I was simplifying option 1, I'll circle this for now. When I was simplifying option 1, it turned into option 2, which I'll highlight in blue, x to the 1/6 divided by x to the 1/3. It turned into that. So option 2 has to be true, right? That which means I eliminate choice 2 since it doesn't have option 2 as an option, right? So I eliminate choice 2. Now let's look at 3. I got x to the negative 1/6 here. I'll use a different color. Let's say green. X to the negative 1/6 here, right? As part of the step when I was simplifying option 1, that was also equal to x to the negative 1/6. So since all of those are equivalent to each other, even 3 has to be true. So all 3 of these are true. Whoa, what is going on? I have no clue what just happened, guys. I am so sorry. That freaked me out. I don't know how that happened, but that really scared me. I'm sorry. I might have pushed a button or something, but I'd never seen that happen before, and that was scary. So option three, guys, is also equivalent to all three of these expressions are equivalent because when we were simplifying option one, as part of the step, we got the one in option two and option three, and then it ultimately ended up being equal to the expression we wanted. So the answer is option one, choice four for options one, two, and three. So which expressions are equivalent? All three of them. Choice four. Okay, so let's go on to number 17. A parabola has focus at 1, 2, and directrix at y equals -2. What could the equation of the parabola be? So guys, a parabola, you know, is for a quadratic function, right? Is simply is a parabola by one of the definitions besides the graph of a quadratic equation is the set of all points equidistant from the point known as the focus and the line known as the directrix, right? So I'm going to minimize me so we could see everything, and I'm going to change the color to blue. Okay, so we know the focus is 1, 2. So if I draw a little sketch of a graph, right? So here's my x-axis, and here my y-axis. Now, the directrix is y equals -2. That's a horizontal line, right here, of y equals -2. That's my directrix, is a line, right? Now, the focus is at the point 1, comma 2. So it's 1, and y is 2, right? So here's my focus. Now, they just want to know what's the equation of the parabola. First thing I want to do is get the vertex, and I'm going to use red for the parabola. If I were to count down 1, 2, 3, 4, the focus and the directrix are 4 units apart. The focus is 4 units above the directrix. Half of that is 2. So up 2 units from the directrix, the vertex has to be exactly halfway vertically between the focus and directrix. So right there, I know the vertex is 1, comma 0, right? Now, the other part I'm going to look at, guys, is here's how you get the equation of a parabola from using the focus and directrix. I don't know why I did that. What you want to do is you want to take, there's an equation that goes y equals 1 over 4p times x minus h squared plus k. The first part, guys, hk is your vertex, all right? So h equals 1, k equals 0. So it becomes, just based on that, oh, and let's also continue the other part. The parabola, remember, has to be this equidistant from, all points have to be the same distance from focus and directrix. So it cannot ever cross the directrix. So this parabola would open upwards and not down. Had the directrix been above the focus, the line been on top, and the point focus been on the bottom, it would have opened down. So we have to have a positive leading coefficient, which means 1 over 4p has to be positive. P is the distance between focus and vertex, or vertex and directrix, which is just 2. It would have been -2 if the parabola opened down. So now I could substitute all these values into the equation. I'll do that in red. So if P equals 2, 4 times 2 is 8. So we get y equals 1 over 8. H is 1, so it becomes x minus 1 squared plus k, which is 0. Since k is 0, I don't need to add the 0 at the end. So it should be y equals 1/8 times x minus 1 squared. Y equals 1/8. Y equals 1/8 times x minus 1 squared. Right here, it's choice 4. All right. I think I said I'd go up to number 18 for this video, so I'm going to do that and then wrap this up and continue the rest maybe tomorrow. All right. And it is important to know, guys, the focus and directrix equation of a parabola. There are some calculators where where you could actually find the focus and directrix from the equation. So you could have typed in each of these and then use that, but it's also important to be able to do this by hand. So now next question, number 18. The function p of t equals 110 times e. Remember, e is not a variable. E is an irrational number, right? It's called Euler's number, I believe, or the natural number. So the function p of t equals 110 times e to the all that times t models the population of a city in millions t years after 2010. As of today, consider the two statements. Okay, before I do that, let's make sure we get that clear. P of t is the population in millions. What that means is that if P of t equals 1, the population is not 1. It's not just one person, it's 1 million. So, and the other thing, t is the number of years after 2010. All right, and keep in mind that this exam is from June 2017, and today it's August 2019 when I'm going over this. And they're saying to consider as of today. Okay? I'll be honest, I got stumped by this question initially, right? So the initial population in 2010 was 110 million, right? This, they're saying consider the two statements. The current population is 110 million. If this was the day you took the exam in June 2017, no, that's not true. This was the 2010 population. It's not the current, it's the 2010 population, all right? And it's not, so it wasn't the current in 2017, June 2017 when we took this exam, and it most certainly isn't the current now unless we invented a time machine and went back to 2010, all right? If you did that, let me know because I want to know how you did it. Anyway, so this model supports not one because we don't have time machines yet, right? So we can't go back in time. So that takes out choice one. And then the other one says both 1 and 2. Well, 1 is not supported, so because we don't have time machines. I mean, because let me be serious for a second. Because it says as of today. But the current population as of today is not 110 million. It'll be whatever you substitute for t, where t is the number of years after 2010. The 2010 population is 110 million. Now let's look at option 2. The population increases continuously by approximately 3.9% per year. So here's how continuous interest looks like, guys. If a population or a value increases by a continuous interest, the exponential growth formula looks like this. It's that the population after t years is equal to the initial population, right? So I'll call that P0 times E. E is used for continuous compound interest to the RT, where R is the growth rate as a decimal. The R value, so our P0 or initial value is just 110, which was in millions. So we get P of t is equal to 110, which was 110 million in 2010, times E to the point I just, okay, with the 0.03922t. R is equal to this value right here. This is the interest rate, not interest, it's not money. This is this population. This is the growth rate as a decimal, and it's growing continuously. So the population does increase continuously, that's true, by approximately 3.9% per year. R is equal to 0.039 if I round it to 2, right? And I could have put the 0 here. If I multiply this by 100 to change it to a percent, it's 3.922%, which is 3.9%. 3.922 is the same as 3.9% if we round it, right? So this is absolutely correct. The population increases continuously because of the E by approximately 3.9% per year. This is true. So our answer is choice 2, 2 only. All right, 3.922% rounds to 3.9% per year, which means choice option 2 is good, and choice 2, which says option 2 only, is correct. All right. I only want to circle the actual answer choice. Okay. So that was it, guys. I felt like that was a trick question. I'm gonna call it a wrap for today because it's 1:52 a.m. right now, and I have to wake up at like 6 a.m. tomorrow. I'm just seeing what we got. This is what we have to look forward to tomorrow. Not a lot. Um, okay, so I hope you found this useful, guys. If you did, please hit like, subscribe. Please send your friends over. I'd appreciate that very much. Not only because it helps me, but because the more people I could help, the better. And if you have any questions, please feel free to leave them in the comment section below. If there's anything I could help you with or explain differently, anything you'd like me to do differently, if you feel like I made an error, please feel free to let me know. All right, I promise I don't bite. And I have to find out what was that glitch in my computer that made it just spaz out, because that was freaky. I've never had that happen before. I hope it was just me pushing a button and I wasn't like hacked or something. Anyway, good luck, guys. Do your best. Bye for now.